is an atom. So students, yesterday we have discussed about the experiment done by whom? Rutherford, student of J. Thomson, right? So what was his conclusion? Let me write once again. Okay. So conclusions drawn after alpha ray scattering experiment by Rutherford. By Rutherford. So students, so this was a completely revolutionized, this experiment have revolutionized the field of science regarding understanding, our understanding how an atom will be. Okay, so this gave us the primary basic idea of what an atom is composed of and how these subatomic particles are present in the atom. So first one was first conclusion. Okay, most of the space in the atom, so nearly 90%. So is empty. Is empty. Why this conclusion has been drawn? It is not necessary. Most of the space in the atom, okay, is empty because why? What is the reason? Means most of the rays, okay, most of the rays, what is alpha rays, have not deviated. Deviated means what is this? If the atom, like what Thomson have proposed, like completely atom completely filled with the positive charges, most of the rays by hitting positive charges, we would have bounced back. Bounced back due to repulsion because already alpha rays are dipositive. And Thomson told that the atom is fully composed of positive charges only. Fully positive charges only, and very rarely negative charges are present like the seeds in the watermelon. So majority is positive charges. What was told by Thomson is majority. So if everything was positive charge, then these rays which are once again dipositive, okay, they should revert back. They should majority of the rays should revert back. That did not happen. That did not happen. Okay. So this concept is wrong. Okay. So this concept is wrong. So that's why most of the space in the atom is empty. That was the first conclusion. And then the second one is okay. The positive charges are confined. So confined means what? Limited. Okay, limited to the center of the nucleus. Center of the nucleus. Center of the nucleus. The positive charges are confined to the center part of the nucleus, which occupies the volume very less compared to volume of atom. So the difference between the volume of atom in the nucleus is nearly 10 power 5 times. Okay, that means if the volume of the atom and the volume of the nucleus are compared. Okay, so if you think that this is the X atom minus X nucleus, the difference is 10 power 5. Okay, so that means atom is 10 power 5 times greater than, that means the volume of atom is 10 power 5 times nearly greater than that of the nucleus, greater than that of the nucleus. Okay, so there is a huge difference. The entire mass, okay, entire mass is concentrated in the center of the atom, the volume of the atom. Then electrons revolve around the nucleus, like planets revolve around the sun. Planets revolve around the sun. So therefore, this model, Rutherford's model. Okay, now we will come to the atomic model. Okay, so what are the postulates? So these are the conclusions that are wrong. Okay, by Rutherford after conducting the experiment, alpha ray experiment. So he gave the model in 1898. Okay, in 1898, this experiment was conducted in 1897 under Rutherford's model. Okay, Rutherford's postulate. So Rutherford's postulate of atomic model. So what is the model of Rutherford proposed? Okay, how an atom will be made. The same thing we can write. Atom contains most of the space to be empty. Entire particle charge is because see why entire particle charge? Why you see he don't know where the particle charges and whether particle charges are there or not. Because why he is saying the entire positive charges are confined to the center of atom called nucleus. So why he is saying it? See, he is saying that electrons are revolving. Okay, electrons are revolving around the nucleus. Suppose. Okay, electrons are revolving around the nucleus. This is the center of the atom. Okay, this is the nucleus. These are the electrons. So these are electrons, and this is the nucleus. Now he is speaking only about electrons. He is telling that the positive charges, not even proton. Be careful. Okay, because proton was discovered afterwards, right? So what he is saying is electrons are revolving around the nucleus. He is saying, and he said that the entire positive charges are confined to the center part of the atom. This is the atom. This is the nucleus. Center part of the atom. Okay, why he is saying this means atoms are not these electrons are negatively charged. Okay, electrons are negatively charged. Okay, but protons or positive charges are unit positive. So if you have to check the charge of electron, 9.27 into 10 4 minus 27 coulomb something it is. Okay, and the charge of proton is somewhere around 1.6 plus 1.6. Okay, into 10 to 4 minus 27 coulomb, something like that. Okay, whatever. And if you see the charge. Okay, anyway, this is electron is negatively charged, and positive charges. Positive charges are in the center. So therefore, as the atom is electrically neutral, okay. So atom is electrically neutral. That means, for example, if you have to speak, suppose this is a marker, okay, or else, okay, this is a marker, and, okay, this is a duster you are seeing, and this is a clock, okay, and then suppose, okay, right, this is a book. So everything is comprised of matter. So everything is comprised of matter. So when we are touching this, we are not feeling the shock. Yes or no? Electrically neutral means this is the meaning. Okay, suppose if you touch a iron wire or some metal wire where the electricity is passing, where the current is passing, you touch it, you will receive a shock. Okay, there we say that it is the electricity is flowing there. But here, even if the electrons are present in every substance, atom is electrically neutral. Why means we assumed that the electron, that means the charges of electrons, whatever the number be, it is being balanced by some positive charges. Like that he assumed. He assumed that positive charges are present like that, and also due to the experiment, because the alpha rays were bending, they are having certain angles. Okay, sideways bending, and some very few were head-on, that means they came backward. Okay, so he assumed that okay the entire positive charge is confined to the nucleus. Okay, one thing, and the entire mass also concentrated here only. So positive charges and the mass of the nucleus is confined to the center part of the atom. And as the atoms are as the substances are electrically neutral, okay, he assumed that the number of electrons are balanced by the same number of positive charges. And where these positive charges are present? They are present in the center of the atom, the nucleus of the atom. That's how he generalized that this is electrically neutral. Understood? So that is the second postulate. So let us see the third one. Okay. These are revolving. Electrons are revolving around the nucleus. Electrons are revolving around the nucleus. Electrons around the nucleus like planets revolving around sun in circular orbits. Underline this one. Planets revolving. So this model of atom, Rutherford hence Rutherford's model of atom is also called as nuclear model or planetary model also. Planetary model. So why nucleus means in the atom there is a nucleus. He was the first person. He was the first person to say to express that atom is in spherical shape and there is a nucleus also in that one, and that contains the total positive charges or total positive charge. The entire positive charge in an atom, okay, is confined to the nucleus, and that is also comprising 90% of mass of the atom also. The entire mass, if it is 100%, okay, 90% of the mass of the atom is due to the nucleus. 90% of mass of atom is due to the nucleus. Understood? So that's why it is called as nuclear model or planetary model. Why planetary model? See, Electrons are revolving around the nucleus like the planets revolving around the sun in circular orbit. So point to be noted is concluded is he corrected. Okay, he made changes to the model of Rutherford's atomic model by modifying a few points. So what are those few points? Let us see now. So what he said is, okay, positive charges are confined to the center of the atom. Suppose if this is an electron revolving around this charge, it has to collapse. It has to collapse. Okay. So if a charge is revolving around another charge, what happens is, if a charge is revolving around another charge, so what should happen is, suppose, see, this is the nucleus, this is the nucleus of the atom, and an electron started revolving around this. Okay. So it has to collapse into the nucleus. It has to collapse into the nucleus. That means it should follow, it will follow a spiral path. It will follow a spiral path. See, if a charge, see, there will be a force of attraction between these. Yes or no? What is that? Electrostatic. We say that electrostatic force of attraction. See, what are the basic forces in nature? Basic forces in nature. So you might be knowing this very well. The basic forces in nature are gravitational force, so strong nuclear force, then weak nuclear force, and electromagnetic force. Electromagnetic force also can say. Okay. So these are the basic forces in the nature. Gravitational force is a very long range force but very weakest among all. This is the weakest, but the range is very long. Means our sun is able to hold all the planets, even though they are some thousands and lakhs of kilometers away. Some thousands and lakhs of, suppose you think of from sun to Neptune, Uranus, Neptune, they are very far now. Okay, so lakhs of kilometers. Even then, it is able to hold with its gravity, and make them to revolve around the sun. Right. So first one is the gravitational force and the strong nuclear force. The force which is present between the particles of the nucleus. That is what we are discussing here. Nucleus. After this only it came into existence. Then weak nuclear forces. There will be certain forces in the nucleus which are very weak also. Strong nuclear forces are there. Weak nuclear forces are there. For example, strong nuclear forces means between the force between the proton and neutron. Neutron still we did not discuss. That I will tell after this. Okay. So like that, there are some subatomic particles other than proton, neutron, electron, called as muon, pion, etc. Very small particles. Okay. So the forces between those we call it as weak nuclear force, and finally the electrostatic force of attraction. That means the force which exists between any two static charges. Suppose positive and negative. Okay, a positive charge and negative charge means they will have electrostatic force of attraction or repulsion. If the charges are opposite, there will be attractive force. If the charges are same, means positive, repulsion, negative, repulsion. North pole, repulsion. South pole, repulsion. North pole, south pole, attraction. Like that. Okay. So electrostatic force of attraction will be there. So as a result, what happens is, okay, the electron will be losing its energy. Electron will be losing its energy. Means the frequency, okay, the frequency of radiation is equal to frequency of rotation of electron around the charge. Okay, that means here what is happening is this electron, suppose it is having certain energy. Okay, sure, no doubt in that. So due to electrostatic force of attraction, what happens is it starts losing energy. Okay, that means it starts radiation means emitting. Start emitting energy, and at what frequency does it emits that radiation means it is equal to the frequency of rotation. That means it is revolving around this path is of okay, cycles per second. If the path is circular, what do we say? Cycles per second or hertz. Okay, so the frequency of radiation, that means the frequency of energy which it is emitting is equal to the frequency of the rotation of around this charge. So what happens is after some time it has to lose its energy. It has to lose its energy. Okay, and then what? Collapse into the nucleus. It has to collapse into the nucleus. Okay. So in this force, okay, when electron is revolving around positive charge. Okay, what happens? It gradually loses its energy and collapses into the nucleus. As a result, atom should collapse. As a result, what should happen? Atom should collapse. But is it happening? Okay, is it happening? Atom has to collapse. Means what is the meaning is the atom should not exist. Means the matter should not exist. Are you able to see matter? Here matter means solids, liquids and gases every time. Same meaning. Okay. So we are able to see solids, liquids as well as gases. Matter is not collapsing. We are able to see that clearly. Okay. I am seeing this table in the form of table. I am seeing the fan in the form of fan, door, cupboard, benches, everything it is there. That means atoms are stable here. So that means this is not correct. So finally he came to a conclusion that okay, this is not correct. Means what is the criteria here? So he took this point. This point means electrons are revolving around the nucleus like planets revolving around the sun in circular orbits. Like planets are revolving around the sun in circular orbits. If it has to happen, because these are charges. Okay, planets are revolving around the sun. Okay, orbits are not circular. Okay, that is elliptical. That's okay. We will leave it for now. Okay, here the gravitational force is different from electrostatic force. Okay, electrostatic force is very large in magnitude but very small in range. See, the diameter of nucleus is nearly 10 power minus 6 to 10 power minus 9 meters. See how small the size is. Diameter of the nucleus of an atom is of this order. What is the order? Micrometer. This is the order of a micrometer. Micro, mega, pico, mega, giga, tera. These are all the suffixes you will be having in your material. You can go through it. Okay. So this is the order of the nucleus. That means the electrostatic strong nuclear force or weak nuclear force. So at what distance, at what range, range means distance, at what range they are existing, means the range is this much. Range is micrometer. That means 10 power minus 6 into 10 power minus 9 meter. The range is very less, but the magnitude is huge. Okay. So that is about this one. So what should happen? Here this is not happening. The atom is not collapsing. So that means, okay, this postulate might be wrong. So this was corrected by later a scientist called Niels Bohr. What is the name of the scientist? Is Henry David Niels Bohr. Okay, what was the scientist to correct this? Once again, there is a do alteration or changes to the model of Rutherford is so Niels Henry David Bohr. See, so don't get wondered by this name. Okay, because we also have the names like Veera Venkata Mohana Muralidhar, Veera Venkata Satyanarayana, and still lengthy names will be having. Same, like us also, there also. So, what we say is Niels Bohr, or simply otherwise Bohr, that's all. Bohr's model. Okay? Bohr's model of atom. So, what did he do is, he modified this one. He modified this postulate. That means, okay. So, as usual, atom contains most of the, okay, what to say that? Postulates are same, even the Bohr also. Okay, all these are same. So, what was the part modified by him means, okay, he started from this point only. Okay, so electrons, okay, here the first postulate is becoming electrons revolve around the nucleus, of course, revolve around the nucleus in discrete orbits. He is saying discrete orbits. What is meant by this discrete orbits? So here discrete means discrete orbits are shells. So discrete means here fixed. Okay, means fixed orbits, right? So therefore, discrete means what is the meaning here? So like that, by moving so they do not radiate or they do not absorb energy. That's all. So he modified that. This is in fixed orbits. Okay. So while revolving so, while revolving in discrete orbits, they do not. They means what? Electrons here. They means electrons. They do not absorb or radiate energy. Hence, do not collapse into the nucleus. Okay, do not fall into the nucleus. So, are you able to see this? They do not fall into the nucleus. So, these discrete orbits, okay, orbits are shells. Okay, orbits are shells are represented by alphabets like K, L, M, N, etc. or 1, 2, 3, 4, etc. Okay, students. So these were the postulates, or these were the modifications done by Beach Bohr to the model of Rutherford's model of atom. These are okay. These are everything is nice, but first and second point okay. But the third one okay. So here we don't have any name to this. The name of first one before the Rutherford was Thomson model. The name other names of Thomson's atomic model. What can you say means either plum pudding model or watermelon model. Then Rutherford model. So what can you say nuclear model or planetary model? So this planetary model only is continued here. Bohr's model we don't have any particular or specific name. Okay, specific name is not there. So first he took only this point only and then he framed 3 more points. Electrons revolve around the nucleus. But what discrete? Suppose you have a rack. Okay, you have a rack of books in your house. Okay, so you can either adjust books either in one rack, upper, lower, middle, something like that. Okay, between each rack there is a partition. Yes or no? There is a partition. So that means either you can keep the rack in first, second, or third, or fourth something. First, second, third, fourth something, but not in the middle. But not in the middle. So that is what he is saying. Okay, when these electrons are because he has to explain this one no. So if one charge is revolving around another charge. So as per the electrostatic, what is the Coulomb's law? That is Coulomb's law. So this law was told by Coulomb. Okay, that when there are two electrostatic charges or static electric charges, okay, there will be a force of attraction between them, which is directly proportional to the magnitude or product of those charges and inversely proportional to the square of their distances between their nuclei or square of distances. So that means, for example, if there is a dipole, okay, two charges are Q1 and Q2. So the force of attraction between these two is given as F is equal to okay 1 by 4 pi epsilon naught into K into Q1 Q2 by d square. The distance is d. Okay, so the force of attraction between any two positive charges. Okay, it is not visible. Coulomb's law. Already Coulomb has told that is as per the Coulomb's law. This one, suppose this is one positive, this is another positive charge. The force of attraction. Okay, F is equal to okay, how is it 1 by 4 pi epsilon naught into K into Q1 Q2 by d square or r square. This is the distance between these two. Okay, this is the distance between charges and the Q1 Q2 are the magnitude of charges Q1 and Q2. Okay, so there this is the constant and this is the medium between these two. That means whether those two charges are present in air or water or some liquid, etc. So this is K. And the Q1 is the magnitude of first charge, Q2 magnitude of second charge, d square of the distance between them. Okay, so we have this one in gravitation also. Okay, gravitation force between two masses. Suppose there are two masses M1 and M2. So two masses M1 and M2 means F is equal to G M1 M2 by d square. Where G is the universal gravitational constant. G is the universal gravitational constant. So like that it is electrostatic constant. Okay. So our electric permeability we call this. So like that, as per Coulomb's law, surely there is a force of attraction between two charges. Force of attraction between two charges if they are present at a distance apart. If they are present at a distance d away from each other, at a distance d away from each other. So as per that law, okay, as per Coulomb's law, okay, here the electron has coming to the nucleus and the atom should not exist. But we are seeing the atoms and matter is existing. So it is electrically neutral. So hence what we did is they revolve around the nucleus of course, but not like what he said, but around a fixed, a discrete orbital. Discrete orbitals are the same thing. He gave the name as shells. The shells are also called as shells or orbits, or you can call them as main energy levels. Main energy levels. So once you are speaking main energy level, so there are sub energy levels also. So sub energy levels are also present. So where will you study this? So this was modified once again by Sommerfield because he told all these things, but he did not change this. What is the term? Circular orbits. Who? Bohr's model. Okay, Niels Bohr, he did not change this circular orbit. So what are the drawbacks? So is it completely successful? No. It could explain only the hydrogen and hydrogen-like atoms. Hydrogen means what? Hydrogen contains one proton, one electron. Okay, it is able to explain. So Bohr's model is able to explain the presence of or the revolution of this electron around Bohr's, around one electron and one proton. Right. If you take multiple electrons system, that means the atoms which have more than one electron. For example, helium, lithium, beryllium, boron, carbon, oxygen, etc. So on. So this model could explain the atomic spectra. Spectrum means the emission released by these electrons when they are revolving around the nucleus. Okay. So the emission spectra of multi-electron system. Spectra of multi-electron system was not explained by Bohr's model. So another scientist is called as Arnold Sommerfield. Arnold Sommerfield. So he modified this Bohr's circular orbits into elliptical. Okay. So he modified, of course, everything is nice, but the path they move is elliptical orbits. In a elliptical. Okay. So even this also had some contributing. So after that, okay, due to some phenomena invented in the field of science like black body radiation or Compton effect or this photoelectric effect, okay, by some scientists, even this was not able to explain them. So another model by Max Planck, okay, Planck's quantum model, Max Planck, okay. So quantum mechanical model was to be adopted. Means an atom, if you have to describe the main energy, sub energy levels. Okay. So now we are following this quantum model or quantum mechanical model of the atom, which contains four quantum numbers. So principal quantum number means this one only. Principal quantum number or main energy level. Main energy level. What I have said. Main energy level, sub energy level, subshells, and then finally number of electrons. Okay. So how many electrons has to be accommodated in an atom? How many electrons will be there present in a particular energy level means? Okay, there is a calculation, there is a formula to calculate that one. So because we have written here, the energy levels are indicated by either K and okay. So how many electrons will be present there for means? So how many means what you say? Suppose if this is an atom, okay, or this is a nucleus, okay. L, M, N. Suppose if it is consisting of say 1, 2, 3, 4, so on, and then so on. So this is the first energy level. So this is the first energy level, second, third, fourth. So the same thing can be represented by numbers also. First energy level, second energy level, third, fourth, so on. So you may get a doubt. Okay. You are saying the first energy level, this is the first energy level, and again indicating with K. What is this? We should have A, B, C, D, E. No, sir. Is it a valid doubt? Is it a valid doubt? So here the numbers are 1, 2, 3, 4. But here the alphabets are K, L, M, N, Y. I too don't know. You either Google it because I studied like this. I didn't get this doubt at the time while I was studying. But if you ask me this doubt, I don't know. Because the system it is adapted like that, we are studying like that. Okay. So that either you Google it or you ask somebody. Okay. So this is the case. So what did Sommerfield do is okay, first part or the first this is the one. So here after the second one is like this. And then third one, fourth one. So this is Sommerfield's model. This is Sommerfield's model. So what did Sommerfield do is he kept the first orbit circular only. First orbit is circular only. But L, M, N. The remaining all are in ellipses. Okay, elliptical orbits. Elliptical orbits. Now, how many electrons will be present in each one means? Okay, these energy levels we are indicating 1, 2, 3, 4 now. So, it is equal to 2n square. Suppose if n equal to 1, in the first energy level, how many electrons are present? So, you substitute 1 in this formula. Okay, this formula. So, that is nothing but 2 into 1 square. So, that is equal to 2. Next, 2 into, sorry, next one is 2. Second energy level 2 into 2 square. So that is equal to 2 into 4. That is equal to 8 electrons. So how are they again distributed in this atom? Means okay, we will explain that one also. So how they are getting distributed means there is an order actually. Okay, there is an order. The first one will accommodate only 2 electrons as per this one. Okay. So then the second one. So first one will contain only 2 electrons. 2 electrons. So the second cell is second energy level. Okay. If n is equal to 1. If n is equal to 1. Okay, this is the case. N is equal to 1. If n is equal to 2. Okay. If n is equal to 2, how do you draw? Okay, this is the nucleus. The first one you will have 2. If n is equal to 2, therefore 2 into 2 square is equal to 2 into 4 that is equal to 8 electrons. So in the second one here you will have 1, 2, 3, 4, 5, 6. So the second energy level can accommodate maximum. So first energy level can accommodate. So accommodate means what? It can hold. Okay, accommodate only 2 electrons. Then second energy level can accommodate how many? 8 electrons. Accommodate 8 electrons. 8 electrons. And third one you can go on like this. So third one means 2 into 3 square. Third one means 2 into 3 square. So 3 square how much? 9. 9 to 18. And similarly fourth one 2 into 4 square. 4 square is 16. 16 into 2, 32. So, like that. But there is another rule also. We are writing this one for hydrogen, no? So, hydrogen is containing one electron and one proton. That's all. Okay. And helium, one proton and one electron. So, helium, two protons, two electrons. So, lithium, 3 and 3. Okay, lithium. If you write lithium, see, I am drawing the structure for lithium. Okay, lithium is, it is its atomic number is 3. So this is the first energy level, 2 electrons. Lithium atomic number is 3 now. So lithium atom. So in the second energy level, its capacity is 6, but there are only 1 electron. Are you able to understand? So unless this is filled up, you cannot go to the next energy level. So that means lithium is 3 means like this. Okay. Beryllium. So beryllium, so lithium is equal to atomic number is 3. Beryllium atomic number is 4. Okay, how will you draw that? 1. Okay, 1 and 2 electrons here. But in the second energy level, okay, 2. 2 plus 2, 4. Similarly, boron, 5. So that means how will you draw? 1, 2. Second energy level. Total how many? 5. So 5 minus 2 is 3. 1, 2, 3. And you can go on drawing like that. Okay, that means until the second energy level is filled. So boron 5. Okay, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and then neon 10. So on. Then sodium 11, magnesium 12, aluminum 13. It will be going on like that. So you have to fill up like this only. You have to fill up like this only. So while filling up like this, we get the concept called as what is that is valency. What is valency? Means it is nothing but the number of, like what we have discussed earlier. The combining capacity of an element is called its valency. So what is that combining capacity? How we decide that combining capacity? By seeing this one, atomic structure. Okay, by seeing the structure of that atom, how many electrons are present in its outermost. See, this is the nucleus, this is the first cell, this is the second cell. See, this is the nucleus, first cell, second cell. So this is the outermost. This is the nucleus, this is the first cell. That one only is the outermost. So this is the outermost here. Next, lithium. So nucleus, first one, second one, outermost. So this is the outermost. Then beryllium, core, nucleus, first cell, second cell, or the outer cell. Then boron, fire, nucleus, first cell, second cell, or the outer cell. If you write for carbon 6, okay, I'll write it now. Okay, I'll write. So like that, the number of electrons in the outermost shell of an atom is called its valency. So whatever the number of electrons are there in the outermost shell, that will be its valency. We'll discuss that one now. Okay, right. Okay, students, welcome.